ITU itself is not a regulator. The ITU oversees the international treaty where every nation in the world agrees on which types of wireless services will use which parts of the spectrum. And that is called an allocation. And the ITU spends years studying sharing and coordination in order to decide, yes, these two services can share, or no, they can't. And so the allocations are done every 4 years at a worldwide radio communications conference. And then each nation has its own regulator. And each nation then takes that treaty, the decision on the allocations, and decides what's best for its own country. And every nation has the right to do something different. Most nations don't. Most nations follow the ITU's allocations because if you try to use spectrum in a way that doesn't coordinate with the user or the operator or the country next to you, you both interfere. You interfere with each other. So your own service suffers. So you have no incentive to be a bully and just take the skies and do what you want. You have to coordinate or your own service suffers. So most nations follow the ITU. And if they don't, for instance, a large nation like India, a large nation geographically, might decide that within its borders, it can do something a little different. Maybe it's been decided it will be a terrestrial wireless, but maybe India thinks, specifically, I need that for my emergency response, or I need that for the new 6G terrestrial service. Or maybe they decide, you know what, I really want to use it for satellite. I don't need it for my terrestrial services. And so the nations, any nation will make its own decision about what's best for itself with its national regulator. So the nations make the regulations, the ITU makes a treaty allocation, and then individual nations are the ones that give the license. Once they decide, yes, we're going to use this band for 5G, for FM radio, then an operator has to request a license to get the right to use the spectrum in the country. So the ITU doesn't do licensing and it isn't a regulator. I have to start by asking you and the world not to use the term mega constellation, only because none of these constellations has 1 million satellites. Mega does technically mean 1 million. And so when you use it in another context, it's usually meant to inflame, to frighten. Oh my God, a mega monster, a mega constellation. And having worked for many of these constellations, I'm not frightened. I think they are going to be a revolution in connectivity. That said, they are very large, some of them. And so the ITU was designed to handle, by and large, traditional one at a time satellites up a geostationary orbit. So now we have multiples of tens and hundreds and even thousands of satellites coming in as a unified constellation working together. So the ITU has had to update its software, and the world has had to think about coordination on a global scale, because these constellations are effectively a shell around the entire globe, as opposed to just one over here shining its footprint only on one country sometimes. Certainly a geostationary satellite can cover 1/3 of the globe, which is the beauty of that particular orbit. But some of them were put up just for single nations. And so really they didn't need to worry about what the other 3/4 of the globe was doing. Now with the constellations, it has to be a global agreement, a global harmonization. So the ITU software has had to be updated, and the constellations themselves need to coordinate with other constellations and the geostationary satellites and the terrestrial users. So it multiplies the coordination almost exponentially. Always a concern for national regulators is supporting the small business enterprises, and also universities. A lot of the newer small sats are being designed and built and launched by engineers at university level. So you don't get much smaller than academia. I think that space will always be a challenge for a small player. Space is still incredibly expensive and risky. You can put $5 billion into a system and still have it fail. So most small players aren't going to start in space unless they can do these CubeSats or scientific experiments. And that's a very exciting field. The problem is many of the smaller satellites can't be maneuvered, or they can't be maneuvered well. And so they become an obstacle in outer space. Not to say that they are debris, but to say that all the other operators have to move around them. So the small sats, a great entry-level opportunity, but rife with problems for the larger players, to be honest. And it's not just because the larger players, again, are being bullies, but honestly, they have to take all the burden of maneuvering and getting out of the way of the small sat. Terrestrially, I think there are a lot of opportunities. And in particular, I think there are opportunities in the supply chain. So always looking for better manufacturers, cheaper, lighter weight. A lot of the constellations have an issue with reflectivity. They can be seen twinkling like new stars in the sky. So improvements in paint and materials, all of these are ways that small new players could get into the space business and the spectrum industries without necessarily being the operator themselves. Almost like I set myself up for this question. I feel like this is the one of the key discussions right now. So these constellations are so new, no one is sure exactly which architecture will be successful. Starlink seems to be very successful, but that doesn't mean that the Chinese Huawei or the OneWeb out of Europe won't be equally successful, or that in fact another constellation might come along. So they're new, we aren't quite sure. And one of the big surprises was the impact on radio astronomy. As I said, no one had realized that it would be like 10,000 new satellites in the sky. And so the satellite manufacturing industry, the operators, are having long, deep discussions with the dark and quiet sky astronomy community. Nobody wants to affect basic science and research into the origins of the universe. Everyone cares, especially everyone in the space field. So they are talking about better materials, materials that don't reflect, ways to use software to forget that the satellite just crossed your line of vision. They talk about putting the astronomy instruments on the satellites, so they're seeing beyond the satellite. They talk about putting some of the major telescopes on the moon or on their own space station. So again, right in the middle of this conversation, there has been an impact. Everyone is concerned. Everyone is talking. That said, I don't think the constellations are going away. It's not like the world will stop launching the constellations because of the impact. So we have to go forward knowing that both of these uses are valuable to humanity. Debris, a slightly different issue. The new constellations, although they number in the hundreds and thousands, aren't really the problem with debris. The new constellations are designed for demise. It's one of the terms that's used. They're designed to deorbit, to burn up in the atmosphere, to be grabbed, to be grappled by the new debris removal companies. They're designed to be removed. They shouldn't be the problem. The problem, by and large, is the old materials, the old rocket bodies, old satellites. The older they get, they break up. Sometimes there have been intentional tests to see if there's a ground-based missile system, for example. Sometimes there have been accidents. Astronauts drop wrenches. So there's debris out there, and the debris, that's a problem for all of the satellites. And the world, again, is talking about how do we clean up the big pieces? How do we clean up the tiny pieces that can't barely be tracked, but they're like a bullet when they hit your object? And so debris and dark and quiet skies are really the two key conversations happening between these shared users of outer space. Again, the question, how many of the questions do we have now? 3, 4? Spectrum policy changes constantly as new technologies come along. Some years ago, the old analog broadcast television was transformed to digital, and the old spectrum band was used for, I think, 3G cellular. And as other things advance and compress and we improve our efficiency, we fit new uses in. One of the goals, one of the dreams of the satellite industry has always been direct to an ordinary handset. They've long had satellite phones, big things, but you can carry it on your back. You know, it wasn't, it was transportable. Man packs, they would call it. The militaries were always buying them. People out on ships would get satellite telephone, but they had a big, terminal on their ship. So that's not as sexy as just walking around with your cell phone. So you may have heard that several companies have now found ways of being able to at least text direct to an ordinary handset. And what's happening is either the satellite is putting the cell phone spectrum on the satellite, or the cell phone is building the satellite spectrum into the cell phone. So Apple is using an existing satellite system to offer emergency services around the globe, coming soon to a country near you. But a different company, Starlink, is using the cell phone company's spectrum. They've put it on their satellites for a similar service, so that if you use that particular cell phone operator and you had an emergency and you were not near a cell tower, you would go directly to the Starlink satellites. So what's happening is the batteries are becoming better. Nobody wants to put a powerful battery next to their head. So, that's always been this, at least 500 kilometers away, how strong a battery do you need? And can you get the bandwidth wider? So we've got texting. You can be sure that voice and video are being worked on by everyone around the world. And what this means for regulators is, do I allow satellites to use terrestrial spectrum? Do I allow the terrestrial companies just to have satellites? And what about the cell phone operators? Do I need to license them at all? Can I just license satellite? So big questions, and there's going to be turmoil, and there's going to be unhappiness as some service is going to realize it's not needed. You may not be old enough to remember, but the first cell phones really were just voice. And if you wanted to text, you had a separate device called a pager. And the pager was on your belt or something ridiculous. And you would send a short text, usually just your phone number. That was all you could afford. And someone knew, oh, I'd better call. Let me get my phone and call the phone number that just texted me. Then BlackBerry realized they could do texting on the phone, and you had 2G with texting and phones. And then Apple broke it wide open with the smartphone, with a basic computer and applications on it, with 3G, 4G, and now, of course, we're looking at 6G. And so what happened to the pager companies? Well, they had a great business, and then it went under, and they had to transform. So we are probably at a point like that with spectrum, where regulators are going to have to think very big picture about what's best for their people. How are they going to get the most services to the most people in the most affordable way? And I think it's going to be a period of some turmoil. First, GTO is a very specific term, meaning the geostationary transfer orbit. And that's when you launch something, the vehicles usually can't get to geostationary orbit. They launch it to a lower one, the transfer orbit. And from there, it turns on its own little motor and it putters its way up to geostationary. So geostationary is usually called GEO or GSO, just to clarify on the initials. And then actually both any orbital location is a request from a country to the ITU, whether we're talking a geostationary location or a lower or medium Earth orbit. A nation will basically submit paperwork to the ITU. It's called a filing. You file your paperwork and you request two things. You request an altitude and a spectrum band. So you'll say, I want to launch to 270 degrees east GEO using the C-band. Or you'll say, I'm going to launch to 500 kilometers low Earth orbit using the KU band. And it's the ITU never says no. The ITU doesn't say, ooh, there are a lot of people at that same location. The ITU says you have to coordinate. If you can find a way to share that altitude, that spectrum, that's great. The more the merrier. And if you can't, the nation that submitted its paperwork before you really has priority. So with the geostationary arc, the world decided to allocate specific slots to specific countries for broadcasting. So they would always have the right to a slot to transmit broadcasting television. So there was an agreement. It was a band sharing agreement. But for the other kinds of satellites, it wasn't allocated per country. So it was not that kind of equity. If you think of equitable access as I'm entitled to the same thing as every other nation, that's not the way it ends up working out. And some of that is okay, because again, space is expensive. And a lot of countries, most countries in the world, can't afford to launch and operate their own satellite, but they can participate in a satellite. There was a time when a country would get a one like television channel called a transponder, and or they would put their own television payload on a satellite owned by another country, or they would participate as investors in a larger constellation. And I see that happening with both Guowang in China. I think they're getting investors from other countries. I see it happening with OneWeb, which started out as a British company and then had large investment from India and France and Japan and Korea. More and more countries, and even the companies within countries are investing in shared infrastructure. So I think that kind of equity will always be there. It is true. I think everybody senses that Starlink, which was authorized by the United States, has dominated. There's no question. Their owner company, SpaceX, also dominates the launch vehicle. Their company, Tesla, dominates electric cars. There is something incredibly inventive about that company. I don't think the rest of the world needs to worry that they have the skies to themselves. The space is large, and the altitude they've chosen, 500, is no more magical than 550 or 450 or 600 or 650, right? So we can space the constellations in a way that is physically safe. And the question does become spectrum coordination, but it's really not much different than any other system where they were there first. You will have to invent a system that can share and coordinate with them, but you aren't stopped from going up with your system if you can coordinate. And so I think it'll happen. I think there will be competition. I think they're first to market, but they won't be the only one, especially if it's a money-making market. If this is something a private industry can make money in, other companies will enter. That is literally the definition of a market, right? So I think that the concept of equitable, if we think of it as a broader opportunity to participate in both the operation of the constellation, but more using the services. Every nation can use the services and improve every single one of the Sustainable Development Goals. Do you need to find water? Do you need to find information? Do you need to educate your community? This can all be done via satellite. These constellations are, they're going to change immigration. Why leave your hometown if you can get a degree from Oxford and work for the Hong Kong Financial District, right? I mean, this is going to transform nations just using the satellites. So necessarily owning and operating your own doesn't need to be the goal. There are a couple of good places. The first is the ITU's own website. They have a lot of information. They have the history. They have explanations of how all their working parties and study groups work and operate together. Your own national regulator has a good website, and it can explain how they participate with the ITU or getting licenses to their own national operators. And I think there's also a great book called The Handbook for New Space Actors, put out by a foundation, the Secure World Foundation. I'm looking behind me, but you can't see behind me. I have a copy, but not at hand. The Handbook for New Space Actors. I think it's free, and it really outlines all the things you need to know to get started, and then, approach your own regulators, your own ministries. If you say, this is it, I want to do this, I want to be part of this industry.